All right, what do you want to start with, Josh? Number 2, number 4, 5, 6, 7, 8?
Let's do 2. Just work on the page, I guess.
All right, number 2. Number 2, it says A of t is 20t cubed minus 6t, and it says that s of -1 is 2. And it says that s of 1 is 4, I think. Is that right? And we want to find a function to represent v of t. Well, to find v of t, we have to integrate a of t. True? Acceleration integrated gives you velocity. What does that give you when you integrate that? You go up to t to the 4th, divide by 4, it should be 5t to the 4th minus 3t squared plus some constant. Well, we're not given any initial conditions with the velocity, so that makes it difficult to determine what that constant is. So what we'll do is we'll just integrate again to get a position function, which will give us t to the 5th minus t to the 3rd plus that constant c times t, because that constant is just a number, right? Suppose that's a 7 or something, that would give us a 7t. Right? And then we also, since we integrated, we have to add in another constant. Let's call it d. Why not? D is the letter that comes after C, Tom. That's why I chose D. Like what? Donston? Donstant? Okay, so then we'll plug in -1 for our t values. S of -1 should be 2. So -1 to the 5th minus -1 to the 3rd minus, if t is -1, that's a minus c, and then plus d. Everybody good with that? Josh, you good with that?
Yes.
All right, so we end up with 2 equals -1 plus 1 minus c plus d. Or we get 2 equals d minus c. Yeah? And then we'll also want to plug in 1 and get 4. So we get 4 equals 1 to the 5th minus 1 to the 3rd plus c plus d. And that tells us that 4 is c plus d, or d plus c. And so now we just have 2 equations with 2 unknowns. So we'll solve that system of equations. You can either solve for one of the variables in one of them and substitute in, or you can do linear combination. We'll just, I don't know, why don't we just solve? We get d equals c plus 2. So 4 equals, well, if d is c plus 2, c plus 2 plus c, what does c equal? Looks like c equals 1. And if c is 1, d is 3. And so you can go back in, you can write your position function or your velocity function. Velocity function ought to be 5t to the 4th minus 3t squared plus 1, because that was c. That's the answer to part 2. And then part 3, you would just plug in your c and d values into here and evaluate when the position or when the t value is 0, if you were doing part 3. Good with that one? Everyone good there? That's a fun one. You gotta get a little system of equations over here. Pretty exciting. Yeah, exciting. Okay, everyone's good? Y'all are very quiet. 4, was that the next one you wanted?
Yes.
All right, number 4, a stone is thrown straight up from the top of a building. Its initial velocity is 40 feet per second. It takes 4 seconds to hit the ground. And what do we want to know? We want to know the height of the building. So we want to know the height at the initial time when it was first thrown. In order to do this, we're going to need to know about the acceleration due to gravity. What's the acceleration due to gravity? They gave it to you. It is -32 feet per second. It says it up there at the beginning. In questions 1 through 10, a of t denotes the acceleration function. The acceleration due to gravity is negative 32 feet per second squared. So v ought to be negative 32t plus some constant. And let's see, we know that we can find that constant because when t is 0, the velocity is 40. So velocity of 40 equals 0, right, when t is 0, plus our constant. So the velocity function is negative 32t plus 40. And when it hits the ground, that'd be when the position is 0. So we need a position function. They've been using s, so we use s. S is negative 16t squared plus 40t plus some other constant, as Tom would say, plus constant. I've shaken my head with shame at that, though. And then how do we figure out what that constant is? We know that it takes 4 seconds for it to hit the ground. And like we said, the position is 0 when it hits the ground. So we'll say 0 equals negative 16 times 4 squared plus 40 times 4 plus d, which gives us what? I mean, that's what 4 squared times negative 16 is. So what does that come out to be? What is it? 416. Oh, this is a plus, sorry. I have a minus there. It should be a plus. It was a plus. So what does it come out to be? 96. Our constant is 96, so that tells us that our position equation is negative 16t squared plus 40t plus 96. Well, what is the position of the thing at t equals 0? That'd be the height of the building, right? Because that's where we threw it from. So at t equals 0, the position is 96. Height of the building is 96 feet. Does that make sense? Josh, you get there?
Wait, so I see how we got D, but then
The
so how-
position at t equals 0 would be the height of the building, right? The height of the building is the position of the rock.
yeah, got it.
Whatever it is at 0, so we plugged in 0 to get 96. Does that make sense?
Yes.
All right. And then you wanted number 5 also, is that correct?
Yes.
All right, the maximum height is reached by the stone in question 4 after how many seconds? Well, the maximum height would be when the velocity is 0. So velocity equals 0 if negative, what was it, negative 32t plus 40 equals 0. So that'd be t equals 40 over 32. Divide those both by 8, you get 5 over 4. Good with number 5?
Yes.
Yeah. All right. Wonderful. Number 6. You still want number 6, right?
Yes.
Okay. Number 6. If a car accelerates from 0 to 60 miles per hour, 0 to 60, in 10 seconds, we want to know what is the distance it travels in those 10 seconds with a constant acceleration. 60 miles per hour is 88 feet per second. Okay, so what is the distance traveled? So car is going from acceleration of 0 to 60, constant acceleration. What is the acceleration? The acceleration is 88 goes from 0 to 88 in 10 seconds. So it ought to be, if it's constant acceleration, the acceleration ought to go from 0 to 88 in 10 seconds ought to be right, 8.8 feet per second, right? That should be our acceleration. That's just the total change in velocity over the change in time. So what is our velocity then? Our velocity is 8.8 t plus some constant. What's that constant? When t equals 0, what is the velocity?
0.
0, right? Because it went from 0 to 60. So we plug in 0 for velocity and 0 for t. We get a constant of 0. Great. So we now have velocity is just 8.8 t. So what is the position? Because we're interested in the position or the distance that it travels, right? The position ought to be 4.4 t squared plus some other constant. Well, what's that other constant? What is the position of this thing at t equals 0?
0.
0. So what's that constant?
0.
0. So s is just 4.4 t squared. And so we know that all we have to do is take the 10 seconds, square it, multiply it by 4.4. Looks like that comes out to be 440 feet. Choice E. Good?
Yes.
Mm-hmm. Correct. Or you could alternatively just do this, an integral from 0 to 10 of 8.82. That'd be fine too. Yep. Either one is good. All right, number 7. 7, right there. A stone is thrown at a target. Velocity is 100 minus 20t. It takes 1 second for the stone to hit the target. We want to find the distance from the sling, apparently it's in a sling, to the target. So we're looking for distance, which means what are we going to have to do with our velocity function? Just going to have to integrate it. Where should we integrate it as an indefinite integral or as a definite integral? Does it matter? We can do it as an indefinite integral and solve for the constant, or we can just do this. I mean, this is always its velocity, right? So we can just integrate it from 0 to 1 and see what its change in position is in that 1 second. What does that come out to be? Should be 90. So it must be 90 feet away. Good? Everyone's good with number 7? Josh, you good with number 7 there?
Yes.
Wonderful. I mean, if it's just talking about a change in its location, what the change in position is, you can just use the definite integral. We could have, we did. Well, I mean, we didn't initially, we used an indefinite integral, but then we said we could also do it with the definite. All right. Number 8. Let's see, what should the initial velocity be if you want a stone to reach a height of 100 and you're throwing it straight up? Okay, so if you throw it straight up, what is the acceleration? Negative. What's our velocity? Negative 32t plus some constant. What's that constant? The constant is the initial velocity, right? We're not really given an initial anything here except in the height. We're not even really given an initial height. We just want to know how fast to throw it to make it go 100. But we know that if t equals 0, v equals v naught, right? So if t is 0, v is v naught, that means the constant is v naught. So we have the velocity is negative 32t plus the initial velocity. So we'll need that in a second here. And then we'll integrate again to find the position. S should be negative 16t squared plus v naught times t plus some other constant. Right? And well, we're just throwing this thing straight up from the ground, right? So what's the initial position of it going to be? 0. So we have 0 equals 0 plus d. So we can get rid of that d. So we know that the position is negative 16t squared plus v naught t. And we want the height to be 100. So we will say 100 equals negative 16t squared plus v naught, constant there, times t. And what can we do from there? What? I don't think we're gonna, I mean, sort of, yeah. Okay, what's our initial velocity? Yeah, I mean, we can say that our initial velocity is what? Yeah, our initial, well, no, but that's not going to help us. Well, yeah, that'll help us. No, that won't help us. Yeah, I'm trying to listen to what you're saying, but it's hard to hear you through your mask. So, oh, okay. So what are we going to do? Yeah, it won't help. What are we going to do? We got to go back to this equation somehow. I don't know why I circled that one. Somehow down here, we got to go back to this velocity stuff. Well, I mean, V naught is just, if you plug in 0 for t, V naught is just V naught. So. What do we need to do? Didn't you all do these? Josh is the only one that asked about it. You didn't do any of them. Wonderful. Yeah, so do that, and we're also doing the differential equation multiple choice. What are we going to do? guess I'm gonna have to pause. What is the other piece of information we have? We have that it's hitting this height of 100. What do we know about it when its height is 100? If height equals 100, velocity is 0. Does that help us at all? Right. We can relate this velocity. We could say that the, or not this one, but this one down here, the velocity is 0 at the time at which it hits this height of 100. So the t at which it hits 100 here is the same as the t at which it hits 100 here. So if we were to go in and say 0, I keep circling this one, but if we go in and say velocity is 0, we get 0 equals negative 32 times the time we're interested in plus our initial velocity, which tells us that at the time we're interested in, our initial velocity has to be 32 times whatever that time is. So we can go back in and replace our initial velocity with 32t. So we'll end up with 100 equals negative 16t squared plus 32t times t, 32t squared, which will give us 100 equals 16t squared, which will tell us that it hits that height when t is the square root of 100 over 16, which would be 10 over 4, which would be a time of 5 over 2. And so if we want to know what the initial velocity is, then all we have to do is plug that back in into our initial equation, right? And what was our initial, that's what we're looking for, right? We're talking about a velocity of 0, and so we'll just plug it in. 0 equals negative 32 times 5 halves plus our initial velocity. Just 5 halves. This is 116ths, right? So square root of 116ths is 10/4. So 5 halves. And then we'll just add that over there. And what do you end up with? Looks like that comes out to be 80. Yeah. That was a little bit, I don't know, a little bit more complicated. I wouldn't expect anything that's quite that difficult on the test. What is that, choice B? Make sense or no? Yeah, right, Tom? You think so? Wonderful. That's great. Josh, is that helpful?
Yes.
Oh, great. Anybody else have any other questions? We've done pretty much the first page here.
Can you go over 21 and 24, please?
Wait, what about it? Oh, you only heard me talking about the miscellaneous figures. I told you guys earlier in the week that we were going to do these ones today. Well, we'll do whatever ones Justin, I keep calling you Justin. Josh has. Which ones did you say, Josh?
21 and 24.
You guys are always looking at these as we go through. You have the same book? Yeah. It's a mediocre book. 21, dy dx equals k over x. And y equals 2 when x equals 1. Y equals 4 when x equals e. We want to know y equals what when x equals 2. So let's integrate. What do we get if we integrate this? Y equals k times the natural log of the absolute value of x. Everybody good with that? Plus some constant. Yeah, we have two constants, k and c. That's exciting. Similarly to that first one that we did way back at the beginning here today, because we have two different unknowns here, we're going to have to take two different initial conditions, plug them in to find that unknown, or both of those unknowns. So we end up with 2 equals k natural log 1 plus c. And we end up, well, we'll do this one first. What is natural log of 1?
0.
0. So we have 0 times k, which is 0, plus c, which is just 2, equals the constant. So then we have y equals k natural log absolute value of x plus 2. And we're going to plug in y equals 4, x equals e. And what does that give us? That gives us that k is also 2. So our equation ends up being y equals 2 ln absolute value x plus 2. When x is 2, we get 2 ln 2 plus 2. And that is not one of the answer choices. Perfect. So you'll have to rewrite this. 2 ln of 2 is the same as ln of 2 squared. You can bring that coefficient on the logarithm in as a squared, right? Y'all remember doing that? So this becomes natural log of 4 plus 2, which is an answer choice E. Good or no? Great. What was the other one you said, Josh?
24.
24. 24. We have a solution curve has been superimposed on the slope field shown at the right. Okay. All right. So here is the solutions to the slope field. Look like this, basically. And it says your options are y prime is tangent x with y of 0 equal to 0. Y prime is cotangent x with y of pi over 4 equal to 1. Y prime is 1 plus x squared with y of 0 equal to 0. Y prime is 1 over 1 plus x squared with y of pi over 4 equal to 1, or y prime is 1 plus y squared with y of 0 equal to 9. All right. Good or no? Everyone good there? Yeah. Okay. So the first thing that we will note is, let's see here. First thing we should look at probably is which of these, if one of these comes out really nicely to be like, when we integrate it, it looks like a tangent, doesn't it? Okay, so the solution looks like it should probably be tangent. So that's probably going to eliminate choice A, right? Because the integral of tangent is not tangent, right? It's, what is it? Negative natural log absolute value of cosine. Same with cotangent. The integral of that is natural log absolute value of sine. It doesn't look like cotangent. So A and B don't seem to make a lot of sense. On top of that, we would note that, so I can sort of eliminate A and B kind of right off the bat, just thinking about that. Seems like. That may not be 100%. We may have to go back and reevaluate one of those at the end. But next thing we might look at is that no matter what the x value is, for every y value on there, all the slopes are the same, right? So if you go to that first horizontal line of slopes, these are all like exactly the same going straight across horizontally, right? And then the next line up, they're different, but they're all the same, right? In horizontal lines, they're all the same, which tells us that the only thing that affects the values here is whatever y value we're at, not the x value, right? Because if x is, 7 and y is 1 or whatever, and x is 9 and y is 1, we get the same slope. And x is -2 and y is 1, we get the same slope. So only the y values are going to affect it. Well, these have x values in them. So it really looks like this is the only one that seems to make any sense. I don't know why I put a 9 there. That's a 0 there. And we could prove that that's true. How would we prove that that's true? If dy dx is 1 plus y squared, right? Well, what's the integral of this? This becomes dy over 1 plus y squared equals dx. If we separate the variables and when we integrate it, we'd end up with the integral of dy over 1 plus y squared. That's the inverse tangent of y. A derivative of inverse tangent is 1 over 1 plus that function squared equals x. And if we want to solve that for y, what do we do to both sides? Take the tangent of them, and we end up with y equals tangent x, which is exactly what that curve looks like. Does that make sense to everybody? But the easiest way is to recognize that the x values don't affect those slopes in any way. And you can immediately just eliminate A, B, C, and D straight away from that, because the only one that only involves y is E. Josh, you get there?
Yeah, so if like in a horizontal line, if the slopes are the same, then you know that it's the y value that's changed.
Yes, if for every horizontal line that you could look at the slopes of in the slope field, if they're all, if each horizontal line is the same, every slope in that line is the same, only the y value is affected. And if each, so like if you look at number 23 right before it, in each column, all the slopes are exactly the same, right? And so you could say that only the x value is affected. So for number 23, if you were trying to do that one, you could immediately eliminate choices D and E because they involve a y, whereas the other three do not. They only involve an x, which is the only thing that can possibly affect it. Does that make sense to everyone? Josh, that makes sense to you? Very good.
Yes.
Oh, good. Anybody else? Any other questions?
I have a few more. 33 to 37.
33 to 37. This is like Josh's personal review session here today.
Sorry.
No, it's fine. This is what we were supposed to be doing today. I don't know. 33. Which differential equation has the slope field shown below? All right, so if you're going to look at that one, what do you notice as you go across in the rows at 33?
The slopes are the same.
The slopes are the same. So that means that the only thing that can possibly affect those values is
The y.
the y values. So we can immediately eliminate B, C, and D, which just leaves us with y prime equals y times y plus 2, or y prime equals y over y plus 2. Good? So then you just figure out which one of those makes sense. So plug in a point like the point, I don't know, 1, 1. You plug in 1, 1. The slope should either be 1 times 3, or it should be 1 over 3. Right? So when y is 1, the slope should all either be 3 or 1/3. Well, looks like those slopes are 3 when y is 1. Right? That makes more sense. And you can do that with any of them, and the larger it gets, the larger the slopes. The larger y values you get, the larger the slope should be. Down there at like -1, you'll see that they should be about -1, which is what you've got. Does that make sense?
Yes.
Great. Everybody good with that one? Yeah. 34, you said also, right?
Yep.
All right, 34 says, which function is a possible solution of the slope field shown? So the slope field that is shown, let's see here, we've got, it looks like that any solution that we would draw on it, if it was above the line y equals 1, would be looking like this. If it was below the line y equals 1, it looks like it would look like this. You all agree with that? Okay. So then we just need to go in and figure out which of those makes sense for it looking like that. So y equals 1 plus tangent x, which is choice E. Should look like a tangent curve. Do those look like tangent curves?
No.
No, so it's not that. Do they look like logarithmic curves? They sort of do, right? I mean, logarithmic curves sort of look like exponential curves, 1 plus ln x or 1 minus ln x. But what do we know about ln x? You can only
0.
have positive values of x, right? And, well, it sure doesn't look like these only have positive values of x, do they? No. So it doesn't seem like it would make sense for us to do B or C. Leaves us with only D or A, which is 1 plus e to the x or 1 minus 1 over x. And if the solution was 1 minus 1 over x, it seems like what? What would we have to have there? One minus 1 over x. What is the 1 over x doing? Giving us a what? What do you mean it would have 2 of the curves instead of just 1? It's a rational function, yeah. Yeah, but what does that mean? It would have 2 of the curves. You saying that they would be going the opposite direction. Is that what you're saying? Okay, that's okay. Yes. 1 minus 1 over x, the curves would either be going like this and like this, but not the same direction. Is that what you meant? Yeah. So that's yes. So we can eliminate that. Whereas 1 plus e to the x, they should be going the same direction. Right? And so it seems like 1 plus e to the x is the only one that makes any sense there. We do know that this has a limit as x approaches infinity. A limit as x approaches negative infinity of 1. And it does look like we're approaching a horizontal asymptote of y equals 1 as we go to the left with this curve, right? So that seems to make sense. Good or no?
Good.
Great. All right. You don't like these slope field ones, do you?
I just didn't.
35, y'all looking at the slope field for 35? It's a cool looking slope field. This time we'll note that both the x and the y values affect it, right? The columns are not all the same and the rows are not all the same, right? They both change, true? Which means that our solution for 35 has to include both x and y. So that leaves us with either x squared plus 2y squared plus 1, or x minus 2y plus 1, or x plus 2y plus 1. But both choices B and E, choice B only has y values and choice E only has x values. We have to choose the one that has x and y that affect it. So then what I would do is I would look at a point like, I'd start with something really easy like 0, 0. And I'd say if I plug in 0, 0 to this, it needs to come out to be a slope of 1. Well, if that wasn't helpful, they all do, right? So then we plug in something like, I don't know, looks like at the point 1, negative 1, looks like the slope is 0. Right, 1, negative 1 needs to equal 0. You all agree with that looking at that slope field? Yeah. So plug that into each of these. So if I plug in 1, that's going to be 1. And I plug in negative 1, that's going to be plus 2. And then plus 1. That's not 0, right? Not that one. This one, 1. And then minus negative 2 plus 1. That's also not 0. Eliminate that one. 1 minus 2 plus 1. That is 0. Do that one. Good or no?
Good.
Everyone good here? And I assume you still want 36. Is that accurate?
Yes. I mean,
Okay. So we look at 36. You'll note that the slope field there, both the x's and the y's affected. The columns are not all identical and the rows are not all identical, or each piece in each row or each column is not. So we need the one that has x and y. So that leaves us with x times x plus y as an option. Y times x plus y is an option. X times x squared plus y is an option. We can eliminate the ones that are x times x plus 1 and y times y plus 1. Let's see here. So in the case of this one, the x times x plus y and the x times x squared plus y, anytime x is equal to 0, what should the slopes be? 0. So if we look at when x is 0, looks like it's always 0, true? So those two still make sense. This one, though, that's not going to happen, all right? And this one would say that whenever y is 0, the slopes are 0. Well, if you look there, the only time that the slope is 0, slope with y is 0 is when x is also 0. So that one doesn't make any sense. We can eliminate that one. And then you just plug in some other values and figure it out. So if you look at the point 1, 0, it should be 1, it looks like. So if you plug in, well, those both come out to be 1. So plug in something like, I don't know, how about -1, -1, 1. What does it come out to be if you plug in -1, 1? That looks like it's 0 also. Or that looks like it is 0. -1, 1. And let's see, this one makes that. This one makes it -1 times 0, which is 0. And this one makes it -1 times 2, which is not 0. So it looks like it should be that one. Does that make sense to everybody? We getting the process, the idea of these, feeling better about it? Josh, you feeling better about these now?
yes, definitely.
Oh, great. Let's look at 37. You wanted 37 also, right?
Yeah.
Yeah. So in this one, what do you notice? As you look in the columns, each piece of each column differs, but if you look in the rows, each piece of the row does not differ, right? They're the same. So does the x value matter or does the y value matter?
The y value.
Only the y value matters, right? Because if you go across, right, for every x, it's the same. Right? If x is anything from -10 to 10, as long as y is 0, the slopes are the same, right? So only y needs to be in this one. So that leaves us with 2y over 2 plus y squared, and it leaves us with 2 over 2 plus y squared. And so then we just need to see which of those makes more sense. Find one where it's maybe pretty obvious there that it, if we plug in something like y equals 0, if we plug in where y equals 0, this one would be 0, and this one would be 1. And so it sure looks like that when y is 0, those slopes are 1, not 0, right? So it should be that. Everyone good there with that? Yeah. Anybody else? Any other questions?
I also have 40, 42, 44, 45, and 55.
40. All right. Yeah, a lot of questions here. All right, number 40. The population of a city increases continuously at a rate proportional at any time to the population at that time. Okay. And the population doubles in 50 years. What is the ratio of the population? The initial population is 75. So this is number 40. If the population of a city increases continuously at a rate proportional to the population at that time, that tells us that this is what kind of growth?
Exponential?
Exponential growth. It tells us that this is the change in population with respect to time. is equal to some constant times the population, Kp. And you don't have to solve this differential equation. You should know what the solution to this differential equation is, right? We talked about this. What is the solution to this differential equation? It's the population at any given time is equal to the initial population times e to the kt. Yeah? So if the population doubles in 50 years, if it doubles in 50 years, that means that P is 2 times P naught when T is 50. So 2 P naught equals P naught e to the 50k. That'll let us figure out what k is. So we'll cancel out the P naughts. And we'll take the natural log. Natural log of 2 equals 50k. And so k is equal to the natural log of 2 over 50. And we're interested in 75 years later, right? So the population is the initial population, e to the natural log of 2 over 50 times 75 is our number of years. And so we're looking for whatever that comes out to be. What does that come out to be? This should become what? And you got a calculator, right? Let's use the calculator if you want to. The final population is this, right? It's just 2e to the, what is that? 2e to the 3 halves? Yeah. The initial population is 2e to the 3 halves. And what does it say? Population to the initial population. So it's this over the initial population. What did that come out to be? $8.963. That's not so good. Oh, yeah, that's why, because that's not 2e to the 3 halves. That's a problem. Yeah. Which should come in as a power, so that'd be better. Yeah. P naught, and then that's becomes e to the natural log of 2 to the 3 halves, which is the square root of 8. That'd be better, which is 2 root 2. So this just becomes that population is 2 root 2 times P naught. Screwed up my log rules. And so then we'll take the ratio of that to the initial population, which is just 2 root 2 to 1, which is trace D. That's better if we do our logs right. Does that make sense, Josh? If that was your question.
Yes.
Wonderful. What was the next one you said? 41, 42?
42.
42. All right, 42 says g prime of x squared equals g of x for all real x. It says g of 0 is 0. It says g of 4 is 4. We want to know what is g of 1. All right. So this can be set up as a differential equation. We can take the square root here and just get g prime is equal to the square root of g of x. Yeah. And let's see here. So if we want to, let's see, yeah, if we want to integrate this, that won't work out so great. Let me think about this one for a second here. What's the next one you wanted? We might come back to it.
44.
Which one?
44.
44. Yeah, let's do the 44 for a second. I'll come back to 42 in a minute. I'm going to think about that one for a second. 44 says the point of intersection of a solution curve y prime equals x plus y, and the line x plus y equals 0. We want to know if the function at that point is 0, if the function has a max, if the function has a local min, if it has a point of inflection, or if it has a discontinuity. At the point of intersection of those. Okay. So if x plus y equals 0, that tells us that y prime is equal to, if x plus y is 0,
0.
then y prime better equal 0. Y prime equaling 0 isn't going to guarantee that the function is equal to 0, but it could potentially give us a max or a min. True? So then we would need to figure out, let's see. Or if it has a discontinuity there, wouldn't be a discontinuity because the derivative exists. Could potentially be a point of inflection depending on what the second derivative was. What's the second derivative? Let's just look at the second derivative. The second derivative ought to be 1 plus y prime. And if y prime was 0, then 1 plus y prime is going to be greater than 0. And so if we have a critical value where the derivative is equal to 0 and the second derivative is positive, that tells us it's concave up, which tells us that it should be a minimum. Does that make sense?
Yeah, so you took the second derivative. Okay, so you took the derivative of the y prime.
Correct.
Okay.
Yep, second derivative of that is 1 plus y prime. Yep.
Okay, thank you.
Because we're doing it with respect to x.
Yep.
All right. What was the next one you said? We'll come back. I didn't really think about the other one, so we'll come back to it in a minute. What was the next one you said?
45.
45. Okay. I think this one, I believe, is one that had a mistake in the there. So let me take a look here. We have a slope field for f prime of x equals e to the negative x squared is given to us. And they've put in the solution at 0, which looks like this. And it says, with the graphing calculator, the limit as x approaches infinity of f prime of x, maybe it wasn't this one, should be equal to 1. And so we're looking for the limit as x approaches infinity. It says of f prime there, right? I can't see very well.
I think so.
Yeah, okay. So that's just the limit as x approaches infinity of e to the negative x squared. Yeah, I think this is the one that they made a typo in, because if you just look for the limit as x approaches infinity of e to the negative x squared, that's just e to the negative infinity, which should be 1 over e to the infinity, which should just be 0, and that's not an answer choice. And so, I remember having this issue with this one. What did they say the answer choice was? Okay, yeah. So when you go, it's like in the back of this book, they've got their whole explanation of it, and so in their whole explanation, they say to approximate the limit as x approaches infinity of capital F of x, not just capital F prime. So I think they made a typo when they were originally doing this, and what they were really looking for was this limit, I believe, which could be part of the reason why. Did you get 0 when you tried to do that, this problem?
I didn't really know what to do, so that's why. Like,
Oh, okay. Yeah, so I mean, if it was just f prime, you just look for the limit as x approaches infinity of this, which is 0. But if it was capital F of x, then you need to go through and you need to think about this as if it's an integral from a constant to x of this function e to the negative t squared dt. And you, even though there's no nice easy function that we can get for the antiderivative of e to the negative t squared or e to the negative x squared, you can use your calculator to approximate it. And if you look in I don't know, it doesn't really matter what you use as your upper limit there. You're going towards infinity. Just pick some value that gets fairly large for x. I mean, it doesn't even have to be like big at all, but you could put in 100, it'd probably be good enough. You could put in like 1,000 and just have your calculator approximate this. And let's say x equals 100. And if you do that, you should end up with one of the answer choices. One second. So 0 to, let's say, 100 of e to the negative x squared dx. And so is that the answer choice that they said it was?
yes, I think so.
I think somebody texted you while you were trying to talk, Josh. Anyway, that's what you would do there, is you would just look for what happens is this upper limit gets very large, basically. The larger I make it, it's clearly coming out to be closer and closer to 0.886. Does that help or no?
Yes. So why did we use think of it as an integral to determine the
So
limit?
we treat it as if it's an integral because we're interested, because okay, the original problem said f prime, but what they meant was f of x, and f of x is the integral of f prime. So we have to use an integral.
Okay.
Right, and since we know that f of, I mean, it gave us, I believe it gave us the information that f of 0 was 0, right? That we were using this point, and so that's why we use a lower limit of 0, because that way when we plug in 0, we get 0. Does that make sense or no?
Yes.
We did a bunch like this, except they didn't give you like a slope field to look at with it. And they asked you like not what the horizontal asymptote was, but or what the limit as x approaches infinity was, but they asked you like, what's the value at 7? Well, we just integrated from 0 to 7. Yeah. Is that good or no?
Yes.
All right. Cool.
And then it was 55, the last one.
55? Okay. I was going to go back to that other one now here. But what was 55? cooling corpse. That's fun. All right. We have a corpse from question 54. Oh, man. Okay. Had to do. What was the answer to 54? Just so we have the right.
I got A.
You got A. Was that actually the right answer? Yeah. Okay. Just making sure. All right. So we have dt over dt is negative k times t minus 10. And then, so we just need to solve this differential equation. So if we solve this differential equation, that's going to give us dt over t minus 10 equals negative k dt. We'll integrate it, which will give us natural log absolute value t minus 10 equals negative k t plus your constant. And what did it say? It cools to 27 degrees Celsius in 1 hour. And that gives us the natural log of the absolute value of 27 minus 10 equals negative. Did we get a k value from the free? We didn't get a k value, did we?
No.
No. Okay. So we end up with negative k plus this other constant. So using that original, so using this natural log of absolute value of t minus 10 equals negative k t plus a constant, we know that it started out at 32 degrees. So natural log of 32 minus 10 equals c if t is 0. So our constant is natural log of 22. You guys not going to stay for this? You're done, Tom? This is a question. You don't have to. We end up with natural log. Actually, let's go back up here. So we end up with natural log of absolute value of t minus 10 equals negative k t plus ln 22. And then from there, we know that at t equals 1, our temperature was 27. Yeah, so that'll let you find your k, which I don't know, whatever that decimal is, whatever it comes out to be, natural log of 17 over natural log of 22. And then you'll just plug that back in for k along with your c value. Does that make sense to everybody? You guys think I wasn't trying to like shame you into staying. Does that make sense, Josh?
Yeah.
So whatever natural log of 17 over natural log of 22 is, just plug that in for your k and then plug in your ln 22 for your c, and it should come out nicely enough.
Okay. So we got this C because we knew that when t equals 0, that the body was 32 degrees.
Correct.
Okay.
Yeah.
Okay.
Tomorrow we're going to do that free response one, hopefully, and then further applications of integration. The rest of you in the Zoom, you're good to go if you want. Josh, if you want me to, I can go back and finish that one that you asked about that I didn't do.
Yes.
Yeah. Okay. So I'll keep recording so that people can see it. So all right. Let's see here. So what we're going to do is we're going to work with this, and we're going to say that. Let's see. Yeah. Okay. So. 281. Oh, okay. So what we'll do then from here is say that oh man, I'm not happy with this one. Let's see. Have a good one, Emily. I have to think here for a second. G prime squared is G for all real x. So G prime, or the derivative, is just 2 times the square root of G. Yeah, I'm gonna have to think more about this, and I'll come up with an answer for you and help you with it tomorrow. I gotta think about that a little bit more. Yeah.